So what I'd like to do now is kind of wrap up our discussion and then look ahead at what I think might be coming down the road. And of course, prediction is always hard, especially when it's about the future, as Niels Bohr and Yogi Berra said. So let's kind of think about where we might be going and where we might be swept off to if we walk out the door and go down this road. So the first thing to think about is using generative AI tools is a step towards a broader vision. Now I'm thinking primarily of software development, where we build the systems of the future with humans and these AI tools working together as trusted collaborators. And there's a study that I was a part of from the 2001 timeframe that you can get here at this link. And it talks a lot about this. And if you're involved in computer science or software engineering, you might want to take a look at the study. When we did the study, we realized that AI was going to happen. We just didn't realize that it was going to happen so quickly. So the part that still needs to be thought through is the trustworthy dimension. These tools are not foolproof. They're not trustworthy entirely. You have to apply a lot of critical thinking, which is why augmented intelligence is the way to go. A lot of efforts going into R&D on making these systems more trustworthy and more foolproof, but that's going to take a while to unfold. Where we're headed, and this is true for software, this is also true for almost everything else, is people will think more in terms of the intent, what they're trying to do, rather than the means by which they do it. What does that mean? It means we're going to be focusing on problem solving with these tools, as opposed to conventional programming using Java, C++, JavaScript, Python, R, or whatever. And that's really important thing to recognize. Back in the day when people would come to my faculty and myself from our other disciplines like physics and chemistry and biology and classical civilization studies, and they'd say, we want to use computation to do our research and our teaching more effectively. What we said in the past was, great, we will teach you how to program in Java. We will teach you to program in Python. We will teach you to program in, God help us, JavaScript, these abominations that somehow have gone on much longer than they probably should have. That's not the right answer. It was not the right answer really back then. It's definitely not the right answer now. The right answer is to get people to use these tools to work in a more natural language flavor for much of their computational thinking. Not all. If you want to do high-performance physics computations and simulations, you're probably still going to need to program in C++ or Fortran or Rust or Julia or whatever you want to do. But a lot of other things can be done with these tools. What's nice about this is it'll allow us, you and me, to focus on the creative parts rather than getting wrapped around the axle of these low-level, mundane, technical details. And that's what I'm trying to emphasize in the courses I teach, trying to get AI to do the stuff that's boring so we can focus on the stuff that's fun. By the way, if you ever want to amuse yourself, take the winners from the obfuscated C code contest, which you can take a look at online, and then run it through ChatGPT and see if it can tell what the code does. So there's a contest every year where people try to write really obscure C code, and humans then try to figure out what it means. And so somebody actually did an experiment where they compared ChatGPT versus humans trying to deobfuscate obfuscated code. So if you're into that kind of stuff, it's really funny. As I mentioned before, everybody's going to be a programmer. We've written a bunch of papers on this topic. Something else that's going to happen very quickly is it's going to radically, and I mean radically, disrupt the creation of multimedia content and its consumption. If you haven't seen this already, take a look at Sora, S-O-R-A. If you click on this link, you'll see the video that I excerpt here, which is a new tool that's coming out from OpenAI where you can give it a prompt in English language or whatever language that they support, and it will generate a movie for you that represents that. So this particular scene is, they said, generate a Japanese woman walking down the streets of Tokyo after a rainstorm. And if you watch this thing, if you didn't know it was computer generated, you would have no idea that it wasn't a real scene. And there's a whole bunch of other examples from that website that are really interesting. ChatGPT is even clever enough through its image recognition features to understand geek humor. So let me tell you what I mean by that. So I love, if you haven't noticed by now, I like to have visualizations in my slides to make the points from both a left brain and right brain way. And so I wanted to create a diagram that showed my students the difference between concurrency in theory, which is nice and orderly, and concurrency in practice, which is a big scrum of chaos. And so I first had ChatGPT with its DALL-E feature. I said, please generate me a row of puppies eating out of their bowls in a nice, orderly manner. And it created that picture right there. And then I said, please generate me a scrum of puppies eating out of each other's bowls in a chaotic way. And it generated that image there. So first of all, it's pretty cool, the image generation. But then I wanted to go even farther. I took a JPEG version of this, and I gave it to ChatGPT, and I said, what is this? Like, what is this, and why is it funny? And it was able to look at the image, and then it came up with an analysis of what it meant and why it was funny, which I thought was amazing. And I'll cut to the chase here. So the why it's funny part. The humor comes from the stark contrast between the two scenes. While we often aim for the orderly situation depicted in the theory, reality, as shown in practice, can be far from it. The exaggerated messiness of the second image emphasizes the unpredictable nature of real-life situations, especially when compared to the idealized theory. It's a visual play on the age-old observation that, in theory and practice are the same, but in practice, they're not. Which is a very funny thing that computer scientists say all the time when they get fed up with their theory colleagues who tend to be a little bit fast and loose with reality. And it could figure this out from looking at that image, which just completely blew my mind. Imagine trying to write a program to do this yourself. You probably would be incapable of doing that for the most part, but it was able to do this in about 5 seconds. Now, there's a lot of fear-mongering and doom and gloom, and the world is coming to an end, and if you want to amuse yourself, go search "Is AI the end of the world?" and you'll get all kinds of articles talking about how we're doomed, and the AI apocalypse is coming, and we should stop developing AI for the good of humanity. I don't spend much time worrying about that. There's a lot of other things I think are more likely to cause the end of the world, like nuclear war, like the black hole that's coming our way that's going to consume our galaxy. That's probably going to happen faster than AI will end the world. Too much TikTok. I'm convinced that is more likely to end the world. It probably will rot the minds of Americans more quickly than almost anything else you can imagine. So, of course, if it really was the end of the world, we wouldn't have to think about the future very hard, but I don't think that's really going to be the case. So we often fear that the world is ending, and it's just the beginning of something new. So to kind of wrap up, there's still a lot of work that has to be done. We've got to do a lot more research to make these things more trustworthy and more scalable and more precise. We have a lot of work on developing the tools to make them user-friendly. There's a lot of work on policy and governance and regulation that has to be thought of. But it's easy to jump in. You folks are already way ahead of the game by being able to be learning this stuff in a systematic way in a class. I think that this is the most exciting innovation that we have seen over the past 1,000 years. There's lots of other things on that list that are pretty exciting too, but this one is going to have radical transformational impacts. And one of the things that's super cool is that we have a chance to shape this because it's brand new, and we're the vanguard of this brave new world. However, as I mentioned before, a lot of people don't see it this way. A lot of people aren't ready or willing or able to come up to terms and come up to speed with this stuff. So we're going to see a digital chasm, which is even bigger than the digital divide between people who use AI effectively and those who don't. And that's going to start affecting the workforce as of right now. So the advice is get on board, get ahead, keep ahead. And the keep ahead part's particularly interesting because unlike almost every other field of computing, where as a Vanderbilt graduate, you've got a good head start, but there are probably people who've been doing the same thing for a long time, right? If you want to be a web developer and you go to Vanderbilt, after 4 years, you're probably pretty good, but the people who've been doing this for a couple of decades. But very few people, if anybody, has more than 6 to 12 months of experience with prompt engineering, with using large language models effectively, with using other more advanced techniques like retrieval augmented generation. So a small amount of investment now will pay great dividends as the workforce increasingly transitions in this direction. And that is the end of that discussion.